Hello friends, my name is Suleiman and welcome to this video session on Java Programming Fundamentals. In this session, we are going to learn following topics: object-oriented concepts, Java architecture, Java basic constructs, then we'll see how to create classes and objects in Java, and finally we'll end this session with exception handling. So we'll start with object-oriented concepts. That is module 1 of our session. In this module, we'll talk about object-oriented concepts. And before we talk about object-oriented concepts, we'll brief about uh, what is programming language, what are the different programming languages we have, the advantages and disadvantages of various programming languages. Uh, then we'll differentiate between the procedure-oriented language and object-oriented language, and we'll discuss the object-oriented concepts. So let's talk about programming language. So programming language is a language used for writing computer programs. So what is a computer program? So program is a set of instructions that we give it to the computer. Computer is an electronics device. It cannot perform any operation unless we give the instruction to it. So we write the instructions in the program, and then we give that program as an input to our computer, and then computer produces the output. And there are various things involved in it, like operating systems and the hardware and etc. So we are not going into the detail of that, so we'll stick to what is a programming language. So the programming language which machine understand is machine level language or machine language. So the first form of programming language is machine language. So this language contains only zeros and ones, and internally these are represented using high voltage and low voltage. So if we want to write a program using machine language, my instructions would be something like this, which are going to contain only zeros and ones. Like that could be my one instruction, and this could be another one. So this is a program written in machine language. We can't understand what is this instruction is used for, but the machine understands these instruction sets. So when we say 1, it represents high voltage, and when we say 0, it is a low voltage. So this is the only language which our machine understands, and writing program using machine language is very difficult, because we need to understand the architecture of entire machine, and then we need to write the program. So some machines are 64-bit machines, some machines are 32-bit machines, and there were some 8-bit processors also. So considering the architecture of the processors, we have to write the program in machine language, and that is very difficult. And if we write a program in machine language on one processor, and we take that program onto another processor having a different configuration, that program will not work, because the instruction set has to be modified in order to execute onto a different platform. So this language is a platform dependent language. So you need to understand the platform and then write the code in it. So considering this drawback, and it is very difficult to write the program since it is written in only zeros and ones, binary language. So another language came into the industry, which is assembly language. So this language contains the mnemonics like add, move, subtract, multiply, again move. So this kind of mnemonics uh, which contains in this language. So the processor knows about these mnemonics. So if I execute add, the processor knows what to do with the with that instruction. Similarly, move, subtract, multiply. All these mnemonics have some meaning in the processor. But as we discussed earlier, that machine understand only binary language, machine zeros and ones. If I provide these mnemonics as inputs to my machine, it's not going to work correct because it understand only machine language. So in order to convert these mnemonics into machine language, machine code, a tool is used called as assembler. So this is a tool which converts assembly language code into machine language. So machine language code. So when we convert these mnemonics into machine language, that we can give it to our machine, and that machine is going to execute that those instructions basically. All right, and these language are specific to the processors. Every processor has a different architecture. Hence, every processor has a different registers, configuration, etc. So we have to have a different mnemonics for different processors. So this language again is also a platform dependent language. The code we write onto a processor 1 cannot be executed onto a processor 2, which has different configurations. So this language again is a platform dependent language. So another language was introduced, that is high level programming language. So considering the drawback of this machine assembly language, in which what we do is we write the mnemonics. So in order to write those mnemonics, we need to also understand the architecture of that processor. Then and then only we can write the code in it. So it is difficult again to understand the architecture and then write the code. So that is the reason the high level programming language was introduced. And in this, the program is written using simple English words like printf, scanf. So simple English words are used in high level programming language. But again, these are simple English words that the processor will not understand. That needs to be converted into the machine code. Then only it can execute. So in order to convert this high level code into machine code, we have various tools. So first one is compiler. It is a tool. This is a tool which converts a high level code into machine code. We also have interpreter, another tool for converting high level code into machine code. But there's a difference between these two. So what is the difference? Let's talk about the difference. So in with the help of compiler, when I write a source code, okay, and it has many lines of code in it, few lines of code. What it does, compiler takes the entire code and takes this entire code and convert that to machine code. So at once this process is done, and what we get is a file called as, let's say for example, this is hello.c. So .c is a language, C language code, which is a high level code. So when I compile this hello.c, will generate hello.exe that we can execute at any time. So in compiler, the entire source code is taken and converted into machine code, and that we get a file, exe file, and that we can execute. This is not the case in interpreter. So what happens in interpreter is uh, one by one or line by line, conversion and execution is going to happen. So this, let's say this is my source code. So I have various lines of code in it. Okay, and let's say this again is a hello.c, and I'm using interpreter in order to convert and execute interpreter. So what it does, it takes one line at a time, one statement at a time, converts into machine code, and then executes. Then after executing that statement, takes the second statement, converts, and then execute. Then third statement, convert, execute. So this way we are not going to get any file after conversion. We are directly going to get the output. So this is the difference between the compiler and interpreter. So most of the languages are compiled language. Some languages are interpreted language. Okay. If we talk about Java, Java is both. It is not only compiled, but it is also interpreted language. So this is about the programming language and the different programming languages we have. These high-level programming languages again are categorized into two: procedure-oriented language and object-oriented language. So in procedure-oriented language, programs are written using procedures or functions. And in object-oriented language, programs are written using objects. Okay, so if we talk about procedure-oriented language, I will have functions in it. Like there's a main function, and that main function will call other functions. Those functions are going to perform some operation. So that is one function, function 2. This way you will have various functions into your application, and you will be calling that from your main function. So function 2. So this way uh, the procedure oriented language uh, gets the code, and object oriented language, we create the classes and objects. More onto these object oriented concepts we'll talk in the next video. So thank you for watching. We'll see you in the next video.